All right, so notes three is about margin of error, and which we talked about with the last unit. We did some margin of error stuff, and then we're also at the end of the lesson going to move on to something called matched pair procedures, which is like what if we actually run a study of where we're matching pairs, like we're doing a before and after, or we're matching like two specific people up, kind of thing like that. All right, first up, margin of error. So just like with proportions, oftentimes in a study, we might want to determine what sample size we need before the study is run in order to ensure a certain margin of error. So we want to make sure that this piece of our formula is a specific number, okay? Because maybe it's just what the company wants. They want a margin of error within like a certain number, okay? So we know that the margin of error for our t intervals, okay, was t star times s over the square root of n. Okay, so we can't use like we can't use this like we did with our proportions, because there's a couple issues that are going on here. Okay, first off, cannot find t star without our degrees of freedom. Okay, and what do we need for degrees of freedom? Well, that's going to depend on the sample size. And what are we trying to find out right now? We're trying to figure out how to make our margin of error a specific thing, which is the only thing that we can adjust is that sample size. Okay, so if we don't know the sample size, we can't know the degrees of freedom, and we can't know t star. Okay, so there's an issue there. Okay, we also won't know our sample's standard deviation. Okay, because that relies, of course, on that sample data. Okay, and we haven't even run the study yet. Okay, so we've got a lot of issues coming up to where t star is a problem. Okay, so for this type of problem, when they're trying to set a margin of error, okay, for a means, we're going to end up having to use z star as an estimate for t star. Okay, so we're going to like basically go back to z star with a couple of additional things to look out for. Okay. So another way that we can fix these problems is we can use a reasonable value based on a reasonable value for our standard deviation based on past studies. So they'll look back at like the previous study they did, see what the standard deviation was for that, and that will be a reasonable number to use for the current standard deviation. Okay, because we assume that not like that much is going to have changed with the population between tests. Okay. All right, so let's look at an example. All right. So I'll let you read that, and then you can give it a shot if you want to, but then come back and we will do it together. All right, so this one says they want an estimate to be within 1 milligram per deciliter. Okay, that means our margin of error needs to be 1. Okay, and they want to do a 95% confidence level. So that's going to help us out. 95% confidence level, or confidence interval, is going to give us, or a 95% confidence level is going to give us a 95% confidence interval. And remember, this time we're using z star, okay, which is going to be inverse norm, which is going to be equal to 1.96. Okay, and then we're going to need the population standard deviation, and it says previous studies have shown the cholesterol level in children of this age varies with a population standard deviation of 5 milligrams per deciliter. Okay, so our standard deviation of our population is 5. Okay. All right, so we know the formula, same as it was last time, is z star times standard deviation divided by the square root of it. Okay, and so for this one, we want it to be 1. Z star we know is 1.96. We have a standard deviation of 5, and we are looking for what n is going to be. So this is a little bit of an algebra problem to solve for n here. Okay, and if we divide both sides by 1.96, we're going to get 5102 is equal to 5 divided by the square root of n. Okay, which means a little bit more algebra later. We got square root of n is equal to 9.8. Square both sides, and we get n is equal to 96.04. Right. Okay, and then remember, This is like a specific sample size, okay? So we don't like this decimal, okay? So also remember, okay, once you hit this point, always round up. Okay, no matter what, even though we're really, really, really close to 96, we're going to round this up to a sample size of 97. So they should use 97 children in their sample. Okay. All right, so that's going to be it for this video, and come back